All right, squad, give me a try on something here before I get to it today, if you would. I want you to look at this. In 6th grade, you would have learned how to find the distance on the coordinate plane from, say, A to B. What about the distance from, say, A to C, where it doesn't follow the grid? How would you figure that out? Pause here, do a little work, see what you got. Put it aside, don't erase it after you do it. And unpause when you're ready to go. Because today, I want to teach you how to use the Pythagorean Theorem to find distance. Make this the title on your next free page in your math notebook. And you've done that. Close it up, clear out those distractions, turn those things off, and maximize that brain power. So Pythagorean Theorem, we learned the other day. It is for one way we say it is the length of each leg squared added together. Remember, these are legs, the ones that touch the right angle, equal the hypotenuse squared. That's this. We usually actually see it written a squared plus b squared. The legs get the names a and b, equals c squared. The hypotenuse gets the name. And we would use it to find the length of a triangle, kind of like this. The missing side, kind of like this. So if one side is 5, we can do our a squared plus b squared equals c squared, leg, hypotenuse. The legs are 5 and 4. Add those up, you get whatever c squared is. And that would be, what, 25 plus 16 equals c squared. 25 plus 16 is 41 equals c squared. Gonna need a calculator to know that. 41 and 6.5. So about that is the hypotenuse. So it's somewhere around that, right? So that's what we learned with the Pythagorean theorem already. So I want you to notice a little something here. If I were to try to find the distance between A and C, like that, I could actually do that by putting that same right triangle I just showed you in the connect on there. Remember this guy? Well, if you think about that exact triangle, I could draw that here, right? The distance from there to there is impossible to measure because it doesn't follow the grid. But I could measure this, which I know, could measure this, which I know, and use that to find that, and I've just got that same triangle that we just figured out. So I can use the Pythagorean theorem not only on triangles, but I can also use it to find diagonal distances. So especially diagonals, that's where this really comes in handy. So here, I don't know the A to C, but I do know if I make a right triangle out of it, I can use the Pythagorean theorem just like I used it before. Here's my right angle. So that's a leg. That's a leg. And they'll add up to that missing distance squared. So that's 25. Same as last time. 41 equals c squared. And we already figured out that that means that c equals about 6 4/10. No way to really measure that accurately. So the Pythagorean theorem lets you do it. It also lets you solve problems like these, where if you imagine on a map, what if instead of walking from here to here to here, what if you could just walk straight from the start to finish without following the streets? What if you could just walk straight there? Hard to measure. How many blocks long is that? Hard to measure because it doesn't follow the blocks, but this follows the blocks. 1, 2, 3, 4, 5, 6, 7 blocks. This follows the blocks. 1, 2, 3, 4 blocks. And I can now, I've got a right triangle, so I just have to remember to draw in the sides of my right triangle and can totally find that distance. Now I can use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. One leg is 7, one leg is 4. Those will add up to c squared. That is 49, and that is 16. They'll make c squared. I think that makes 65 when you put them together. Don't forget, we're not done. That's not 65 blocks. It's easy to get here and assume you're done. Not quite. To find c, that's c squared. To find c, I've got to use some square roots. And 64 would be 8, so that's going to be 8 point something. A little, very, very little more than 8. So this is about 8 blocks, a little more, if you could walk straight there. So instead of walking 11 blocks to get there, you could just walk a little tad more than 8, and you'd have it. All right, let's do one together. Pause here. I've got a map. You may not need to write this down because it's going to be a lot to us. This is a lot to write down. In my class, I'm going to give you this tomorrow. If you have a way to pause and write this, you can. I know that would be a lot to copy, though. So the question is similar to the last one. How far is it to travel between the two circled points without using the roads, going directly? And when you kind of look at that, do it in green, looks impossible to know. How would you ever measure that? You can't very well, but you can make a right triangle out of it. If I go down to here and over to here, I can make a right triangle out of it. And if I have a right triangle, I can use the Pythagorean theorem. That's the trick. So it's going to be a squared plus b squared equals c squared on this map. One of the legs is 2. The other is 1, 2, 3, 4, 5, 6. So 2 squared plus 6 squared. The missing side, here's the hypotenuse, the diagonal. That's what we don't have. So that'll be 4. That'll be 36. They'll make c squared. So c squared is going to be 40. So c is going to be... Did I do that right? Didn't feel like I did that right. 40 square root. Yep, I did. A little more, about 6 1/3. Slightly less than 6 1/3. 6.32, we'll say, approximately, since I rounded it. So again, rather than walking 6 blocks plus 2 blocks is 8 blocks total to get there. If you could just walk through everything, it would only be about 6 blocks to get there, a little more than 6. And that, my friends, is how you use the Pythagorean theorem to find distances. Make a triangle out of it, right? Triangle, use that Pythagorean theorem. Hope that made tons of sense. If not, go back, watch these again. Second time through always does the trick. If it did, and you feel like that's a thing you can do when you get to class tomorrow, you're all set, and I'll see you then.